Hello, my name is Christophe Levy, and I am the Scientific Director of the Holcim Innovation Center. I am in the construction materials industry since the late 80s. I'd like first to thank the Rilem for giving me the opportunity to share with you some of the main industrial innovations in the cementitious material field, the ones which did not exist 3 decades ago. Here is the agenda of my presentation. I'd like to start with the mega trends in the construction industry impacting market needs. Then we'll look at the main innovation in the domain of cement and concrete along the whole construction value chain. The main worldwide mega trends impacting the construction materials industry are the following. The global population is dramatically rising from 7.8 billion today to 10 billion by 2050 and becoming more and more urban, from half of the people living in cities today to 2/3 by 2050. We need a strong shift to circular economy. We are obviously in a race for climate, and about 1 in 7 human beings has no access to decent housing, which is absolutely unacceptable. These megatrends are fueling the recent innovation avenues like low carbon, energy efficiency, modularity, circularity, renovation, affordability, but also durability, aesthetics, and digitization. Now, what is an industrial innovation? For me, it's an invention sold significantly or very promisingly in the near future and in different markets. Let's look at the most innovative fields. Firstly, architectural, structural, and environmental design. For components, we will speak about cementitious, admixtures, and reinforcement. Regarding construction efficiency, we will present innovations about digital fabrication, monitoring, and curing. And finally, recycling with alternative fuels and raw materials in cement plants, CO2 recycling, and recycled aggregates. And now, let's have a quick look at the 17 concrete and cement industrial innovations I have chosen. Let's start with the field of design. Regarding architectural design, ultra-high performance concrete is today synonymous with optimum strength, ductility, durability, and absolute beauty when speaking about building facades, lattices, and envelopes. Here are some beautiful and recent examples coming from Serbia, USA, and France. Photoconcrete is another amazing aesthetic concrete innovation for beautiful facades and walls. A specially developed surface retarders is printed onto a film or paper, replicating the original image. This retarder prevents the hardening of the surface of the concrete, which can then be washed or brushed away. A last example of aesthetic innovation, which did not exist 3 decades ago, and which allows to improve the image of concrete, is photoluminescent concrete. Allowing energy savings, this new technology is using synthetic aggregates which re-emit different colored lights at night. If we now move to structural design, a key innovation is the recent development and deployment of low-carbon building systems. On one side, new design tools and concepts allow today to reach important material savings, like, for example, topology optimization, like thin bridges on complex building shapes, funicular, which means fully in compression structural design, ability of robotized construction to deposit the right material exactly at the right place instead of pouring conventional rectangular shapes. On the other side, low carbon footprint concretes are more and more developed today, using less cement, more substitution cementitious like slag, fly ash, fill airs, calcined clays, construction demolition waste fines, and sometimes biosourced components. Today, the extensive use of rigorous and independent environmental product declarations and of life cycle analysis bring credibility and buy-in to these new low CO2 concretes. Speaking about environmental design of a building, an important innovative product which was not available on the market 10 years ago is a cement-based insulation material, a kind of extremely light mineral foam with excellent insulating properties, fire resistant, low embodied carbon, no volatile organic compound, no settlement, and recyclable. This mineral foam is used in insulating concrete blocks, attics, and roofing. Hardscaping is a huge issue in the urban environment and can contribute to flooding and heat island effect. New pervious concrete can help by reaching a drainage rate of 200 liters per minute on square meter and allowing traffic. The combination of vegetation and permeable surfaces increases shade and triggers an evapotranspiration phenomenon. This hinders the heat island effect and is known as sponge city. As last example of innovative environmental solution, new bioactive concrete solutions can help to re-establish damaged marine ecosystems and improve marine biodiversity restoration. Thanks to its adequate pH, rugosity, and porosity, this type of concrete enables marine life to come back. For instance, accelerating the kinetics of algae growth by 4 times, or developing a high correlation of fauna with more than 60 species after only 3 years. Now we can switch to the field of concrete components. In order to reduce the carbon footprint of cement, considerable work is being carried out worldwide to develop new cement substitution products, such as calcined clays. It has been recently proved that calcined clay is very efficient in synergy with limestone fillers, as you can see in the triangle on the left. We need also to mention as innovative SCMs, which have recently been added in some commercial cement, the usage of construction demolition waste, fines, or slags, which are not GGBFS. Many functions are now added to the cement, like waterproofing, plasticizers, accelerators, fibers, color pigments, or even zero dust cement. Here, as an example, the sales of waterproofing cement bags have been rocketing all over the planet. Most of the significant innovative admixtures concern super plasticizers, even if new accelerators based on nano-sized CSH particles are interesting. From old-timer byproducts with retarding effects to much more sophisticated synthetic dispersing polymers like polycarboxylate ether, allowing the birth of many modern concretes. On the right, we must also mention recent innovative complementary admixtures like clay inerting agent allowing the usage of clayish sand and delayed efficiency dispersant, which dramatically improve concrete long workability when used with very high water reducer, PCE. New concrete reinforcements are coming, like fibers, textile, and bars made of basalt, glass, or carbon. And they are very compatible with low CO2 concrete, having usually a lower pH. For instance, innovative carbon pre-stressed concrete panels are reinforced with thin pre-stressed carbon strands. These CPC panels are 4 times thinner with the same load-bearing capacity. Let's now have a look at construction job sites. Digital fabrication is probably one of the new concrete potential disruptors. Robotized placement can indeed simplify the life of contractors, especially for very specific complex shaped concrete elements like wind turbine towers or footbridges to avoid very costly formworks. Or, on the other side, for significant affordable houses on public buildings program. But I think the future of 3D concrete printing will depend on our ability to develop lower carbon footprint inks, generalize the usage of concrete instead of today enriched paste mortar, and improve and develop the 3D shotcreting approach, allowing easy to embed reinforcement. You can see it on the right. Another innovation to improve construction efficiency is the entire concrete value chain getting increasingly digitized with sensors, artificial intelligence, and refined predictive models at all stages of its global life cycle. At the cement and concrete production level, sensors, probes, image acquisition are more and more allowing full automation and predictive maintenance. Customer digital services are a reality today with digital ordering, ticketing, and online information about concrete properties like air content, slump, temperature, but also maturity, strength evolution, corrosion, and cracking risks. Another important concrete innovation simplifying the life of construction job sites is internal cure concrete, using, for instance, the super absorbent polymer technology. Keep in mind, proper curing is sometimes overlooked on job sites. Internal curing is perfectly adequate to ensure the hydration of cement and to control early age shrinkage. Finally, we have reached the last field, I mean recycling. Today, we are able to produce clinker without the need of fossil energy, only with alternative fuel originating from industrial byproducts, bringing enough energy for clinkerization. But also using only alternative raw materials coming from various industries, which are providing the necessary sources of calcium, silica, alumina, and iron oxides. This is a potential revolution helping to limit the use of natural resources such as limestone and clay. The CO2 from the stacked flue gas of the cement plant can now be reused for mineralization, either to store it into recycled aggregates. This is a French national FACADES project on the left, improving their quality by plugging the porosity and ultimately reducing the CO2 footprint of concrete, or to carbonatable cements such as gamma C2S or even OPC to produce low carbon precast pavers, blocks, or tiles. 1 to 5% of fresh ready-mix concrete is usually returned to the ready-mix plant. Instead of being discarded, see on the left side, it can be now transformed into a well-graded granular form that can be reused as aggregates by adding agglomerating powders or cellulosic fibers in the truck mixer. On the right side, demolished concrete can today be processed and treated to supply rather good quality coarse and fine aggregates, and also fines which are reused in the cement production. These innovations allow us to dream about a fully recycled concrete in the near future. After the 17 recent cement and concrete industrial innovations, let's try to imagine how cementitious materials could evolve over the next 3 decades. Firstly, I really think concrete will remain the first used construction material, thanks to its versatility, resilience, beauty, recyclability, and local availability all over the planet. Then I am sincerely convinced that in 2050, concrete will become a net zero carbon and fully circular material using almost no natural resources such as minerals and water. The production of cement and concrete, its placement in more numerous precast plants or on job sites will completely be automatized, robotized, and silent. Carbonatable concrete precast elements using stacked flue gas from cement plants will be very popular. Concrete-based building systems will also dramatically evolve with solutions based on hybrid materials, multifunctional elements, dismantleable and reusable, and also with build more with less spirit. Unfortunately, I am not sure I will be fit enough to personally check all these assumptions, but I am certain that the coming 3 decades of research and innovation in cementitious materials will be as fun and exciting as it has been during the past 3 decades. With this, I thank you very much for your attention, and I'm more than happy to try to answer your questions.